So this right here is a optional video which helps you get started on your tasks for this week. So task 1 is going to be finding the radius if you are given the area and circumference. So this is going to be area and circumference style problems. What I did is on your tasks, I've been including examples for how to solve the problems. I blew up those examples so I can show you step by step how to do them in this video, which hopefully makes it easier. And here I tell you to use your notes from slide 4 and slide 5. So let's go ahead and get started. We're going to do an area style problem and a circumference style problem. So the first thing I'm going to do is read the instructions. For A, I need to find the radius. And for B, if I'm given the area, I need to find the circumference. So here I'm given the area, so I know I need to find the circumference. And when I'm given the circumference, like in example 2, I need to find the area. So for example 1, the area is 50 feet squared. So if I'm given the area, I find the circumference. That's what I'm going to do. First step is going to be finding the radius. Now, I'm given the area, so I'm going to use the area formula, and that is A equals pi r squared. And I'm going to plug in what I know for this formula. I know that A equals 50. So I'm going to go ahead and write 50 right here, pi r squared. Now, as you saw in the previous video, what you're going to do is divide both sides by pi so that you cancel it. Now you are left with r squared equals 50 divided by pi. Hit enter. So that gives you 15.9. Now the opposite of squaring something is to take the square root of it. So if I want to cancel the power of 2, I need to square root it. That cancels it. Do that to the other side, and that gives me r equals square root of 15.9 equals 3.98. So I'm going to round that to 4.0. You can write or 3.99. That'd be totally fine. So here I'm going to write r equals 4.0 feet. Okay? Now part 2 asks you to find the circumference. And if you have the radius, you can now find the circumference. So when I'm finding the circumference, I use 2 pi r. So I'll move this paper up a little bit. So C equals 2 pi r. I don't know the circumference, but I do know the radius because of part A. So what I'm going to do is plug that into this problem. And by now you guys should be pros at this, so it shouldn't be too hard. And you'll type 2 pi r. That gives you 25.1. So the circumference of this circle is 25.1 feet. I'm going to write that here. Okay. Now we're going to go ahead and do example 2. So there's 2 types of problems on task 1. You're either going to be given the area and you need to find the radius, then you need to use the radius to find the circumference, or you're going to be given the circumference and then you're going to find the area, you're going to find the radius, then you're going to use that radius to find the area. Okay, so when I'm given the circumference, I use the circumference formula. So that's step 1, 2 pi r. I don't know r yet, but I do know the circumference is 34 feet. So instead of C, I'm going to write 34 equals 2 pi r. And I'm going to divide both sides by 2 pi. But before I do that, I need to multiply 2 times pi so I know what that number is. So 34 equals 2 pi is 6.3. So instead of writing 2 pi, this is calculator work right here, 2 pi actually is the number 6.3. So it's 6.3r. What I'm going to do now is divide both sides by 6.3. This cancels my 6.3 and isolates r, so now I have r equals 34 divided by 6.3, which gives me 5.4. 5.4. And the unit for this problem is feet, so the radius is also in feet. And I can fill that in for part A, 5.4 feet. Okay, now I need to find the area. I can easily do that because I do know what the radius is. So to find the area, I'm going to write the area formula, which is A equals pi r squared. I don't know the area, so that's going to stay A, pi. And then for r, I already found out that it's 5.4. So 5.4 squared. And I'm going to type that all into the calculator. So, second, pi, open a parenthesis, 5.4, close it, squared, equals 91.6. So the area of this circle equals 91.6 feet squared. Now remember, you square the unit when it is the area. So as you're doing task 1, when you're given the area, follow along this example. When you're given the circumference, follow along with this example. Okay? Now I'm going to switch over to task 2. This right here is task 2, and it's going to ask you the same thing. You're given the area of the sector. You need to solve for r. After you have r, you need to find the arc length. Now on example 2, you're given the arc length. You need to solve for r, and then you need to use r to find the area of the sector. This shows you how all the problems are actually really connected to each other. Use your notes from slides 6 and 7 to help you with these problems. Also use these videos. There's only 2 scenarios of these problems in task 2. So for scenario 1, when you're given the area of a sector, use this first example. And for the problems where I give you the arc length, use example 2. And remember, you can play the video along as you're doing the work so that it helps you follow the steps for your specific problems. I'm going to move the paper up a little bit and read the instructions. So find the radius is part A, and then part B is when I'm given the area of a sector, I find the arc length. And if I'm given the arc length, then I find the area of the sector. And I tell you which formulas to use for which scenario. So when I need to find the arc length, use this. And when I need to find the area of the sector, I use this one. So let's go ahead and get started with part A, finding the radius. So area of a sector formula is A equals theta divided by 360 pi, oops, let me go ahead and erase that, pi r squared. Okay, so I need to fill this out. I know that the area of the sector is 32 feet squared, so I'm going to, for A, plug in 32 equals, I know theta is 64, so I'm going to put it in, pi, and I don't know r. That's what I'm going to be solving for, so r squared. Now, as you remember in the other notes video that we just watched, I'm going to put a little tray right here, and everything in my tray is going in my calculator, so I get one number that I get to divide off. So here's my calculator. I'm going to write 64 divided by 360, close the parenthesis, pi. Okay, and that is, this number is what all of that stuff equals. So rather than writing all that out, I get to just write 0.6. because I'm rounding up. So 32 equals 0.6 r squared. Now whenever I have a number next to r, I just get to divide it to both sides. That cancels it off. And then I have r squared equals 32 divided by 0.6. And that gives me 53.3. And I'm not quite done. I need to square root both sides. So when r is squared, the opposite is to square root it. So we square root both sides, and then I have r equals 7.3. And I look at what my unit is for this type of problem. It is 7.3 feet. Okay? Now I need to find the arc length. So my arc length formula is C equals, we start with theta over 360, and then it's 2 pi r. Well, I know that theta is 64 degrees, so I go C equals 64 divided by 360, 2 pi, and then r is 7.3. So now I just type all that stuff in the calculator, and that gives me the arc length. So I'm going to write C equals, open a parenthesis, 64 divided by 360, 2 pi r. So, oops. And enter. And that gives me 8.2. And I look up at my unit, it is feet, so my arc length is also in feet. It's 8.2 feet. Okay. Now for my second example, I'm given the arc length and I need to find the area of the sector. So the arc length is going to be 15 inches and theta is going to be 90 degrees. So when I'm given the arc length, I use the arc length formula to solve for the radius. So the arc length formula is C equals theta over 360, 2 pi r. First you write the formula. Next you plug in what you know. So the arc length is 15, which means this formula is equal to 15. I know theta, it's 90. 2 pi r. Okay, so as before, I'm going to make a tray that puts everything in the calculator besides r. So open parenthesis, 90 divided by 360, 2 pi. So rather than all that stuff, this all equals 1.6, right, when I round up. So 15 equals 1.6 r. I divide both sides by 1.6. And I get that r equals 15 divided by 1.6. Okay? That gives me 9.4 when I round up. So here I'm going to write 9.4, and I look at my unit, it's in inches, so I write inches right here. Now part B is to find the area of the sector. So I pull out the area of the sector formula. It is A equals theta over 360 pi r squared. Okay? So I don't know the area yet, right? That's what I'm trying to find. But I do know theta, so I can plug that in. That's 90 over 360 pi, open a parenthesis. I know what r is because I just solved for it, so 9.4 squared. Okay, so all I have to do is type this string into the calculator and then it gives me the answer. So A equals pi, oops. Let's do that again. 90 divided by 360, second pi, open a parenthesis, 9.4, close it, squared, enter. So 69.39 rounds up to 69.4. And since this is area, we're going to do inches squared. Okay? Now, I know that this looks like a lot of steps. Take it one at a time. If you're working on an arc length problem, use this part of the video. If you're working on an area of a sector problem, use this part of the video. Okay? Now, the area of the sector is going to be 69.4 inches squared. Okay, and if you have any questions, please email me. I'm happy to help you. I can make you your own video if a certain problem is confusing, but take your time with these videos. You don't have to do it all at once. Make sure you're pausing, taking notes, trying your own problem as you watch the video. I hope this helps. Again, email me if you have any questions, and good luck, you guys.